So now what in this lesson we are going to talk about, first thing we need to know what is probability. So probability is like, the chances, I would write down here like this, the chances of happening or not happening any event. We call it probability. We are doing a kind of forecasting thing. It is part of this. In real life, you calculate, you do forecasting, you predict the future, and future has many different outcomes. I mean, not every time the outcome is the same. What do I mean by outcome? Outcome means that when you throw a coin, so you can either get a head or you get a tail. So in case of a coin, if you toss coin, you can get either heads or tails. So it means that a coin has two possible outcomes, okay? So when you throw a coin, you can get either head or tails. So it means that your possible outcomes are two. You've got two possible outcomes. So when you have two outcomes, so if I ask you that what is the probability, probability means that what is the chance of getting a heads? What is the chance of getting heads? So you say that probability of getting heads is 1 out of 2, because there is one head, there is one heads, and there are 1 divided by 2. There is one heads, and of course there are total 2 outcomes. Or if I ask you that what is the probability of getting a tails, and your answer would be again 1 by 2, okay? So which means 50-50. So this means that this is 50% chance that you may get head and 50% chance which you may get tails. And in probability, you write it like, either you write it like 1 by 2, or you write it like, actually you write it like 0.5 and 0.5. So there are two outcomes. When you toss a coin, either you can get a head or you can get a tail, and both of them, they have equal chance, 50% of head, 50% of tails. And 50%, we call it 1 by 2, or you call it 0.5. So actually these all three things are same. You call it 1 by 2, you call it 0.5, or you call it 50%. It's all the same. But usually we speak like this, half, like 1 by 2 or 0.5. And you should always remember that the sum of probabilities of all occurrences means outcomes, is equal to 1. That is another rule which you should remember. So you have two outcomes here. If you make a total of them, the answer is 1. So this is rule. The sum total of all probabilities should always be equal to 1. So if any event has two outcomes, their probabilities total should be 1. Now we consider another example that, rolling a dice. You've got a dice. When you throw a dice, when you roll a dice, the dice has 6 faces. The dice has 1, 2, 3, 4, 5, and 6. So, I mean, either when you roll a dice, either you can get a 1, or you can get a 2, or you can get a 3, or 4, or 5, or 6. It has 6 faces. So I say that probability of getting a 1. What is the probability of getting a 1? Because the dice has total 6 outcomes, 6 possible outcomes, I would say 6 possible outcomes. I told you last time that we are doing accounting, but within accounting, management accounting, we have one topic forecasting technique in future also. And this is a part of statistic. That's why I asked you before, because this what I'm teaching you, it is actually from statistics, which is used in accounting. So for 1 or 2 chapters, you have to get some knowledge from statistics as well. This is a purely statistics topic. So because a dice has 6 possible outcomes, so we can say that probability of getting 1 would be 1 by 6. And why it does not allow me? I call it 1 by 6. Okay, it is not allowing me. 1 by 6. 1 divided by 6. Okay. And the same goes here. All of these are 1 by 6, 1 by 6, 1 by 6. The probabilities of getting these numbers is 1 by 6 because there are total 6 faces. Out of 6, 1 is one outcome belongs to 1. Out of 6, 1 outcome belongs to 2. So these are the individual probabilities. When you make a total, it would be 1. 6 by 6, 6 by 6 means 1. This is the sum total. I may ask you that what is the probability of getting a number, an even number when rolling a dice. So this is one statement I ask you, that what is the probability that when you roll a dice, you get even number. So how many even numbers do you have on the dice? Your even numbers on dice are 2 and 4 and 6. So it means that the even numbers are 3 and the total outcomes are 6. So the probability of getting an even number would be 3 by 6. And 3 by 6, you may call it 1 by 2. And 1 by 2, you may call it 0.5. So I could say that the probability that of getting an even number. So if you roll a dice and you know that the dice has 1, 2, 3, 4, 5, 6, and I ask, what is the probability that an even number will appear? An even number will appear means either 2 or 4 or 6 will appear. And you say that it is 0.5. Or I may ask you that what is the probability of getting a number greater than 4? Greater than 4. Now, greater than 4 means 5 or 6, okay? 5 or 6. So these are 2 outcomes, 5 and 6. 2 divided by 6 and 2 divided by 6, you can call it 1 divided by 3. Or you can call it, 0.333. So this is the probability, like 0.333, you may call it 33.33% or whatever. So this is some very basic idea of probability. We will not go into details. And by the way, I tell you that you will be using these probabilities in F5 also, and you will use these probabilities in F9 also. So in paper F2, F5, F9, you would face them, at different levels. So we stop here. We do not go into depth. We are not learning statistics, so we don't discuss in more detail. This is all what we need to know. So what you do usually, you should remember that this thing, you should call it X. Now this is what you need to remember. X, we call it X. X means the outcome. And this is called P of X. P of X means probability of X. Okay. So X and P of X. These two, X means any outcome. Okay. You've got outcomes X, like 1, 2, 3, 4, 5, 6. Any one of this could be, you call X. And then you have probability of X, like the probability of this outcome. Probability of X, you call it P of X. Okay. Now, we come back to our topic. Let's suppose that you are starting a project which has following expected incomes. Following expected incomes. Like it is possible that the business results, you got best option, which means that you can earn $15,000. Okay. So you can say that if my business goes good, my earnings could be $15,000. This is the best possible option. It is possible that if the business goes average, I may make $12,000. And if it goes poor, which means that it didn't go well, then I would earn $8,000. Okay. So these are the three possible outcomes. When you start a business, you are not sure what exactly would happen. You only can expect, either I can earn 15,000 or I can earn 12,000 or I can earn 8,000. These are the three possible outcomes in front of you. You are never 100% sure that exactly 15,000 I will earn. You may get more, you may get less. This is what happens in life. Now, when we say best option, that I may get 15,000, then I ask you, what are the chances of getting this value? What do you feel? Are you sure this much? You say, no, I think there is 40% chance that I will earn 15,000. And then what is the chance for 12,000? You say there is 50% chance that I would earn 12,000. And about 8,000, you say, it's a very rare, it's a very little chances, maybe just 10% that only 10% I earn. Because usually I expect this to be more. I mean, 10% is the worst scenario. It's not something very possible. So it is just 10%. And then you find out X P of X. X P of X, which means you multiply X with the probability of X, which means this column multiplied by this one. Because you say that I can earn 15,000, but the possibility or probability is only 40%. So it means the value is only 6,000. Because you are not 100% getting it. You think that there's a 40% chance of getting it. So you multiply the probability with the event. You call it X P of X. Meaning X is the event, multiply by its probability. And then you do the same here. 12,000, you multiplied by 50%. It also gives you 6,000. And then 8,000 multiplied by 10%, it gives you 800. And then you make a total of this. Now, what is this total? It gives you 12,800. What do we call it? This value, we call it expected value of the project. So this project has an expected value of 12,800, which means that I consider all the different possible options, all the different possible outcomes. Either I can earn 15,000 or 12,000 or 8,000. I multiply them with their respective probabilities and I get a number 12,800. So it means that on average, it looks like that this project will give me 12,800. Okay, so this is a number which is an expected value of the project. We call it expected value of the project. And this thing which we made, we call it probability distribution. Probability distribution. So usually in a probability distribution, you make a table type of thing. You make something like a table in which you write down all the events and their respective probabilities and you get expected value. We call it probability distribution. Distribution. Like you did before in last lesson, frequency distribution. In frequency distribution, when you were doing, you show all the outcomes and you show their frequencies. Now I'm showing all the outcomes and I'm showing their probabilities and I multiply them. This thing is called probability distribution. Are we clear here? Yes, Kamal, are we clear?
Yes, sir.
Okay, good. So we make this probability distribution. So usually what you do, you make distribution, probability distribution when you have discrete data, okay? You make it for discrete data. Do you remember what we talked about discrete data last time?
Yes, sir. Here we talk about whole numbers.
Yeah, where there are finite items, okay?
Yes, sir. Yes, sir.
Finite items.
Sir,
This
sir, we
is,
can also say limited.
sorry?
So we can also say limited items.
Yeah, limited number of items. So you can put them here. But when you get continuous data, you make normal distribution, which is a curve. So if you have a continuous data, then your frequency distribution thing would not work. You would be making a normal distribution.
Okay, sir.
So normal distribution is usually in a curve format. So how would it look like? A normal distribution would look like, okay, I'll go back here from the table. I'll go to the book and I'll show you from the book how the normal distribution would look like. So we come here. So we talked about probabilities and expected values. I have explained you. They just explained it in a very small way, but I didn't like it. So I just explained it on Excel, okay? So you have expected value is summation x of p. You make a sum just like we made the sum of all those three probabilities. We had those outcomes, like you've got this, there is a option A and option B. In option A, you have two, either you get 5,000 with 80% or you get 6,000 profit with 20%. And there is an option B, another project, which you can make either a loss or a profit, and their probabilities. So you calculate the expected value of A. Expected value of A, you calculate 5,000 into 0.8, 6,000 into 0.2. The expected value is 5,200. For project B, your expected value is minus 2,000 into 10%, which is minus 200. Then 5,000 into 20%, 7,000 into 60%, and so on. And you get project expected value of 5,800. And because expected value becomes bigger here, you say this is the option we should choose. Because this project, I have two options. Either I could start a project A, or I could start a project B. Which one I should make? So you should make which has a bigger expected value, okay?
Okay.
So this is a usual situation. In this example, since it offers a higher expected value of profit, option B would be selected. So this is the concept, the use of your expected value. Where do you use them? And then they give you some question. You can find it yourself. It's the same thing. These are the probabilities. You multiply it and you get it. Then comes normal distribution. A probability distribution is an analysis of the proportion of times each particular value occurs in a set of items. There are a number of different probability distributions, but the only one that you need to know about for management accounting is the normal distribution. We will talk about the normal distribution. A normal distribution is usually a curve, and you call it a bell-shaped curve, which means that it is equally on left side, equal on the right side. Your arithmetic mean lies here. You remember in last lesson we did arithmetic mean?
Yes, sir.
And here the arithmetic mean is called mu. You call it mu. This is a sign, and this sign is called mu. So mu, the arithmetic mean, is just in the middle. Half of the values are on the left side, half of the values are on the right side, which means that half of the values are smaller than mean and half of the values are bigger than mean. So what are the characteristics or properties of normal distribution? The probabilities of normal distribution, it is symmetrical and bell-shaped. Symmetrical means that it is possible that there are some distributions which may look like this. This is not symmetrical because it is called skewed. You call it skewed. It is skewed on one side, okay? I call it skewed like this, if I could write it here. So this is called a skewed distribution. You may get another distribution which looks like this. So here you've got a lot of values on the right and here we've got a lot of values on the left. So these two we are not going to study in our F2. What we will study will be this one, normal distribution, which has a proper bell-shaped curve. Okay. It has a mean mu. The area under the curve total exists exactly 1. Just like we said that the sum total of all probabilities is equal to 1. So here we assume that the area under the curve, like this portion, okay, this portion, there are different events. So you should, some events, some outcomes are here, some outcomes here, some outcomes are here. So there are different outcomes. There are probably millions of outcomes. Okay. There are infinite number of outcomes. Because now we have infinite number of outcomes, we cannot make it in table. You can make it in table when you have 3 or 4 or 5 outcomes. But when you have thousands of outcomes, you can't make them in table. You make them in curve. So there are like hundreds and thousands of outcomes and they have different probabilities. The sum total of all these probabilities, whatever is here, the sum total of all these probabilities, we call it area under the curve. And that is equal to 1. Just like we learned that sum total of all probabilities is equal to 1. So this is another condition. And last one, we say that the area to the left of mu and is equal to the area to the right of mu. Like the area to the left and to the right are equal. They are 50% here and it is 50% here, which means 50% items on the left, 50% items on the right. So these are some common properties of your normal distribution. The management accounting syllabus specifically says that you need to be able to explain the properties of the normal distribution. So just remember them. Not very difficult. I'm sure you already understand. The importance of probability distribution. Many probability distributions are close enough to normal distribution. Okay, we'll discuss what is that. Now we come here. For any normal distribution, the dispersion around, what was dispersion? If you remember that we said that you have got a mean. You've got a mean, which is middle value. And then you have different values in real life. There are different values. And the difference between these ones, which you called deviations, these we also called dispersions, okay? Because we said that each individual value is certain points away from the mean. And that difference, the distance between the mean and the actual value, we call it dispersion. Okay. So for any normal distribution, the dispersion around the mean of the frequency of occurrences can be measured exactly in terms of standard deviation. Now here we are going to relate. If you remember, we discussed in the previous lesson standard deviation, which was called average deviation, because you had many different dispersions. You have many different deviations. Some deviations were small, some were big, okay, and some points were closer, some points were farther, and you took average of that, average of these distances, average of these deviations, and that you called standard deviation. So what we need to remember here, that if you take out here, now this is what we make that my, mu is here average, and then values 50% are here, 50% are here. So one standard deviation minus and one standard deviation plus. You have 34% of the values. 34% values lie here, 34% values lie here, and you can call it that 68% in total. What does that mean? Let's suppose that your mean, your mu, your arithmetic mean is 25. Let's suppose your average is 25. And you know that your standard deviation is 4. Standard deviation 4 means that on average, each individual value is 4 points away from 25. It's 4 points away from the mean. Like there are some values which are 2 points away. Some values are 6 points away. The average of those deviations is 4. So you say that X bar plus minus 1 standard deviation. X bar plus minus 1 standard deviation is 68%. What does that mean? I will explain. Just be patient. Which means that 25 minus 1 standard deviation means 4, and 25 plus 1 standard deviation means 4. So you get a range of 21 to 29, okay? So you get range of 21 to 29. You say that within 21 to 29, 68% of the values they lie. 68% of the values are within this range. Like I would call this one, let's suppose this was my 25 in the middle, and 1 standard deviation below means 21, and 1 standard deviation above means 29. So I have got a range from 21 to 29. And 68% of the values will be here, 34 plus 34. This is a rule you have to remember. For normal distribution, this is a characteristic. This is not that 1 times 68, 1 times 67. We say that approximately on average, 68% of frequencies have a value within 1 standard deviation. This is one of the characteristics of normal distribution. If your data is a normal distribution data, if your data is normal distribution data, then this would be the feature of that 68% of the values, they will lie within that range. Okay.
Okay, sir.
So you would remember this thing. And it is not that sometime it could be more or less. This is a rule. Okay. 95% of the frequencies in a normal distribution occur in a range of plus minus 1.96. Like 47.5% you go below, 47.5% you come up. So 1.96 standard deviations below, 1.96 standard deviations up. So you get 95% of the values. 95%. Remember, you had different values in frequency distribution. When you made table, you say that there are different employees. They go on vacations, and 3 employees here, 2 employees here, 5 employees here, whatever. We will see this question and you would understand better. So we say that just remember the range. Just remember the range, and we will do a question and you will understand that 95% of the values, they lie between plus minus 1.96. 1.96 means almost 2 standard deviation, okay? It is not 2, but it looks like that 1.96 actually looks like 2 standard deviation. This was actually 1 standard deviation. When I say 1.96, I'm actually saying quite close to 2. So it means that X bar plus minus, for example, 2 standard deviation. It is not 2, it is 1.96, but you can imagine that 1.96 is actually quite close to 2. Okay, so normal distribution tables we will make. And we see here, example, what is the probability that a randomly picked item will be in the shared area of the diagram? So if you remember from the table above, when you have 1.96, you have 47.5 here. And then you go below 1.96 and you have 47.5 here. And together, when you make a total of 47.5, you get 95. So when you get 95 here, so actually 95 is half on the left, half on the right. You will always remember equal here and equal on the other side, okay? Equal on the left, equal on the right. So if they ask here, if they show us a question below, here, what is the probability that a randomly picked item will be in the shaded area of the diagram below? So we call it 1.96 standard deviation. Look up 1.96 in the normal distribution table and you will obtain the 40.475. Now, what you do? There is something which is called normal distribution table. Normal distribution table. You have to find that value from the table. Where is that table? It is given in your book. I will show you on the screen now. Let me open up the table. If I have it here, I will open it up. Give me a minute. What they asked us to calculate was, they said that what is the probability that a randomly picked item will be in the shaded area of the diagram below? That you pick up an item and it belongs to this area. So इसकी probability कितनी है? What is the probability? What is the probability? So we know that this area is 1.69 standard deviation. So look up 1.96 in the normal distribution table and you will obtain the value 47.475. So we go back and we see in our table, this is called your Z table, if you can see it. Yeah?
Yes. Yes, sir.
If you see 1.96 is somewhere here. This is 1.9 and this is 0.06. So you should read like this. First you go from here, first two digits you take from here and the remaining you take from here. So I take 1.9. So this column I go and I go it until it comes down to this point. So this is the value of 1.96, okay? And how much do you see here?
So 0.475.
0.475. You can also call it 0.47%, 0.475%, or 0.475. So if you go back to your book now, so you would see that this is 0.475. They have written it here. And 0.475 is actually 47.5, which was given here. 47.5. And this 47.5 is the same thing which you had on the top. Here we did. That 1.96 plus 1.96, it has 95% of the values. They gave it here. 95% of the frequencies, they lie between plus minus 1.96. So plus 1.96 minus, so this is plus 1.96, this is minus 1.96, and 47.5 here, 47.5 here. So I asked you that where do you get this number? You get this number from your Z table. Okay?
Okay.
This can be seen from the Z table. So let's see one more. So we said that 47.5 into 2 is 95%, which we said is the rule. So now we know two things we have done. We say that X bar plus minus 1 standard deviation. It had values 68%, okay? It is done. Then we said that X bar plus minus 1.96 standard deviation. 1.96 standard deviation. This is 95%. This is also a rule, we have done it. And then you come to another one which says plus minus 2.58. So if you do it X bar, now you are increasing the range. You see, you are increasing the range. You are not going, 1.96 is until here. This is 1.96. Now you are going 2.58, a little bit more. So your area under the curve is increasing. You see, you have got this area. So this is the mean. This is X bar 1 standard deviation. This area is 1.96 standard deviation. And this part is 2.58. So if you talk about 2.58, you are talking about more values. You are talking about more area. So X bar plus minus 2.58 is actually giving you how much? 49.5, which means 99%. 99% of the values will lie within this range. So if you have in a data set 100 values, 99 values will be from this range, within this range, like mean plus 2.58 standard deviation and mean minus 2.58 standard deviation. So we've got three different ranges they have given us so far. 1 standard deviation plus minus, 1.96 standard deviation plus minus, and 2.58 standard deviation. Then it is 99%. So 99% of the values, they lie here. Let's see one question. Prove that approximately 68% of the frequencies have a value within 1 standard deviation. So if we say 68%, it is actually 34.13 to be exact. We go to the Z table, we say what is in, how to say 60, how much are the values are within 68% range within 1 standard deviation. So you can go to your Z table and find out the value of 1 standard deviation. 1 standard deviation. Let me share the table with you. 1 standard deviation means what? 1 standard deviation is here, this one, 1.000. And you see, I'm sorry, not this one, this one. So it gives 0.3413, which means 34% on the left, 34% on the right, which means 68%. So you should be using this Z table. When you will use it for few questions, you will become more confident how to use it. So this is using the normal distribution. Z is X minus mu over sigma. This is your formula. But how do you calculate this Z value? Right now we calculate this one standard deviation. In some questions, you have to calculate the value of Z. So this table which I'm showing you is called Z table. So you calculate the value of Z and then you go to the table. And how do you calculate the value of Z? Z value is X minus mu over sigma. Let's suppose, what is that? I say that your average is 25, okay? 25. And your standard deviation is, say, 4. And let's suppose we are talking about, what do we talk about? We talk about our good friend, which was Afridi. Remember the last lesson?
Yes, sir.
So we said that the average score of Afridi is 25. This is what he makes. And his standard deviation is 4. His standard deviation is 4. So what is the probability that he makes a score of 30? What is the probability that next time when he goes to a match, he will score 30? You want to make this estimation. Do you understand the scenario? Now I'm asking you that what is the probability that Afridi will score 30 runs in the next match? So you say, okay, this is Afridi average. This is a standard deviation. So x minus mu, like, 30 minus mu, which is 25, and divided by standard deviation 4. What do you get here? You get here 5 divided by 4. And when you divide 5 divided by 4, what do you get? 1.25, right?
25. Yes, sir.
Now, 1.25 is your Z. This is your Z score. And now you go to the Z table and you look for 1.25. This 1.25 we see in the Z score. In Z score, this is 1.2 and this is 5. So you come down here and this is the answer. You say 39.44, which means 39.44% chance.
Yes, sir.
Understand?
Yes, sir.
This is how we use it. Now let me go back to the book and we will see. So here they give you questions. Example, calculate the z-scores. Okay, they just ask you to calculate and here you will use the formulas. I will leave it to you. This is the same thing. They are just repeating it again and again. I would just do one question with you. See, this is the question. It says that a frequency distribution is normal with a mean of 100 and standard deviation of 10. So your mu is 100 and your standard deviation is 10. Calculate the proportion of the total frequencies which will be above 80. How many values will be above 80? How many values will be above 80? Now, first thing you tell me, how much is your mean?
Sir, 100.
100. So 80 will be on the left side or on the right side?
Left side on the right side.
See here.
Sir, I guess, sir, left side.
Uh-huh.
Sir, right side, right side.
This is your normal distribution. This is here.
Yes,
This
sir.
is 100 here. So 80 will be here. Yes?
Left side.
Left side.
Yes, sir.
And they ask us that calculate the proportion of total frequencies which should be above 80. Above 80 means this area, also this area, right? All of that. They don't ask you between 80 and 100. They say above 80, which means more than 80. So this area is more than 80. Okay? This area is more. Right?
Yes, sir.
How do we do that? Let's solve it very quickly. So above 80, so they say that this is 100, this is 80. You know that this is 50%, this is 50%, right?
Yes, sir.
So this 50% is for sure because this is total. This total you have to calculate. This is 0.5. But this we need to know. How much is this one? So you use the same thing. You say x bar minus x minus mu divided by standard deviation. X is 80, mu is 100, divide by 10, 2. So you get answer 2. For 2, when you go to the z table and you see the value of 2, it is 0.4772. So let me show it. So for 2, what do you get? This is 2. For 2, you can see the value here, 0.4772. Yes?
Yes, sir.
So we come back to our table. So it means here, for this thing, you have 0.47, I cannot write it here, 772. So this area is 0.4772 and this area is 50. So you total them up and you get 0.9772. So 0.5 plus this one. Because when I say above 80 means that all of this plus all of this. This one is 0.5 because this is total. And this one is 0.4722. So the total is from here to here, you add these two numbers and you get the answer. Let's see one more. Let's see one more. I know it is 50.
Sir,
Yeah.
Sir, I have a question.
Yes, please.
Maybe one thing I'm forgetting, you must have told me, but I don't understand this point, that when we minus 80 minus 100, so the answer would be in the negative,
Yeah, in the
minus 2. Why
negative,
we
so
are
it shows you that, so, but you will ignore negative. When you see negative, it is only means that it is on the left side.
Okay.
I mean, if you pay attention, they write here 2. They don't write
Yes, sir.
minus 2.
2.
So you ignore this
Yes, sir.
minus thing. The minus only means that it is on the left side.
Okay.
Then they ask you another question, that
Hmm.
above 100. So how much would be above 100? I will not solve, you will tell me.
How much would be above 100?
Yeah. You give me the answer and I stop the lesson. This is 100.
So 50%.
You got it. 50%. Now you understand it. Above 100. Where is that thing? Above 100 is the mean. 100 is the mean. The proportion
Yes,
above
sir.
100 is 0.5. You understood it already.
Yes, sir.
Now, remaining thing you will continue, and
Yes.
it is not difficult. In this book they explained it very well. Okay.
Yes, sir.
I mean, if you see the Kaplan book, they are not doing it good, but in this particular book, they have done it good. You continue this lesson. I will have one more lesson on the same topic, not for explaining, but for answering your questions.